وإعادة تأهيلها بشكل فعال، وهذا لأنها هي من أهم النظم البيئية والرئيسية اللي موجودة في دولة الإمارات العربية المتحدة. وقامت هيئة البيئة عام 2020 بتنفيذ برنامج تجريبي باستخدام الطائرات بدون طيار لزراعة البذور، واليوم نحن ننفذ أغلب مبادرات الزراعة من خلال هذه التقنية.
Technologies are going to play a critical role in feeding the future. It's estimated by 2050 we'll have 9.5 billion people to feed, and to do so we need over 50% more calories. Yet we're not making more land, and we're certainly not making more water to feed all of those people. So what we're going to need to do is get greater output per unit of available land or raw material input to farming, and to do so we need technological advancement. And that'll be in a number of forms. That'll be artificial intelligence, smart or precision farming techniques and technologies that enable that data capture to farm more efficiently. But also it's going to be how labor is managed, how people manage farms more efficiently to get greater output.
كيف المزارع يتبنى طريقة ال AI؟ بأنه يتبنى عدة سناسر، أجهزة استشعار رطوبة، وأجهزة استشعار حرارة، وأجهزة استشعار ضغط جوي، من خلالها تكون عنده بيانات مختلفة عن البيئة الزراعية الداخلية والخارجية، من زراعة البذور إلى الحصاد.
I see the future for technology in agribusiness is bright. We're still in the early days of adoption, but I think a place like the United Arab Emirates can serve as kind of a lighthouse, proving these technologies in one of the most extreme environments, and then bringing those solutions to other parts of the world.
بسم الله الرحمن الرحيم. سيدي سمو الشيخ ضياء بن محمد بن زايد النهيان، نائب رئيس ديوان الرئاسة للشؤون التنموية وأسر الشهداء، سمو الشيوخ، أصحاب المعالي والسعادة، الضيوف الكرام، السلام عليكم ورحمة الله وبركاته. اسمحوا لي بداية بتعريف عن نفسي. معاكم ليلى مصطفى عبد اللطيف، المدير العام لجمعية الإمارات للطبيعة بالتعاون مع الصندوق العالمي للطبيعة، وهي جمعية خيرية بيئية في دولة الإمارات العربية المتحدة، ورئيسة مجموعة آسيا والمحيط الحادي 25 دولة التابعة للصندوق العالمي للطبيعة. ويشرفني أن أدير حوار اليوم الذي يركز على الزراعة المستدامة، وسيتحدث عن هذا الموضوع السيد سيباستيان بوير، وهو المؤسس المشارك ورئيس مجلس إدارة شركة فارموايز. وألفت عنايتكم الكريمة إلى أن المحاضرة ستكون باللغة الإنجليزية، ويمكنكم استخدام السماعات لمتابعة الترجمة الفورية. واسمحوا لي الآن بأن أتحدث باللغة الإنجليزية. Your Highnesses, Excellencies, ladies and gentlemen, it is with great honor that I welcome you to today's lecture on sustainable agriculture at scale. My name is Leila Mustafa Abdulatif, and I am the Director General of Emirates Nature in association with WWF, the UAE's environmental charity. Today we have the privilege to hear from a pioneer and an innovator in technology, artificial intelligence, robotics, and agriculture. Sebastian Boyer is the co-founder and chairman of FarmWise, a US ag-tech company that leverages AI and robotics to build precise farming machines that enhance profitability, resilience, and sustainability of farms all around the world. He is a recurring guest teacher at Stanford and a mentor at the MIT AI Collective Program and an advisor to startups in AI and agriculture. Now kindly join me in welcoming Mr. Boyer to start the lecture. Thank you.
Your Highness, ladies and gentlemen, it's a great honor for me to be here in Mohammed bin Zayed Mejlis. Thank you, Ms. Leila, for the introduction. I'm very excited to talk to you today about agriculture, sustainability, and technology. First, I want to start with by introducing you to Josh. Josh is a farmer I know in Salinas, California. He's 43 years old, and farms about 200 hectares of vegetable crops. Everything from salads, broccoli, celery, cauliflower, vegetables that you and I eat on a daily basis, hopefully. Josh is a third-generation farmer, so I want also to introduce you to his family, particularly his grandfather, who set up the farm about 60 years ago, his father, who took over the farm from Josh's grandfather 30 years ago, and 10 years ago, about 10 years ago, Josh took over again the farm from his father. Same land, same crops, but a very different experience. 60 years ago, the production volume of 1 hectare of lettuce was about 20 tons. When Josh's father took over the farm, the production was on average about 30 tons this time. And last year, Josh harvested 35 tons. These numbers are not specific to Josh's family. Actually, they are average numbers of the productivity on a per hectare basis throughout the world for lettuce farming. This has been made possible by innovation, as you guessed. Innovation that his grandfather started to see when industrial fertilizers were introduced. New innovation in the 90s when powerful chemicals were being used to fight disease and insects. And then more recently with GPS and other advances, innovations that Josh could take advantage of. But let's go back to Josh. Josh today faces a range of different challenges that his father and his grandfather did not face. It starts with labor shortages. Josh, again, lives in California. Labor shortages there are pretty acute. He's actually struggling on a monthly basis to find enough people to lay the irrigation pipes, to do the weeding, and to do the harvesting. That's a big challenge for him. It's not the only challenge, though. Water scarcity is actually becoming more and more of a problem for him. California has seen increasing amount of droughts over the past 20 years. So price of water is higher, and there are more and more regulations that essentially make Josh change his practices. Another issue he's facing is the state regulation, which are increasingly, for instance, measuring the residual fertilizers that is found in the rivers next to Josh's farms. All of these different problems are not specific to Josh. Throughout the world, throughout the different regions of the world, different versions of these problems are occurring, and farmers are facing these problems. Actually, these problems are not only farmers' problems. I want to argue here that there are society's problems. Because agriculture only represents, on one hand, only represents 4% of global GDP. That does not look very big. But the fact is that agriculture has a disproportionately high weight in the consumption of resources our generation deeply care about. Accounts for 20% of greenhouse gas emissions. Accounts for about half of the utilization of valuable land. 70% of fresh water is used for agricultural purposes globally. And as the current conflicts in the world are reminding us, food and agriculture are often at the center of geopolitical conflicts. I will add to this that food and agriculture obviously touch us on a daily basis. This is intertwined with society as a whole. And so for innovators, leaders, to have an impact in whatever society they live in, understanding the challenges and the innovation that agriculture is going through, I believe is critical. So let's discuss about sustainability. Why does agriculture need to change? Agriculture sustainability relies on, I will say, 4 major pillars. The first one is land, obviously. Second one is water. Third is labor. And the last one is fertilizers, or specifically industrially produced fertilizers. So let's dive quickly into each of them. First, water. The UN expects that by 2050, 1.3 billion more people will face water scarcity on a regular basis. This is up from only 700 million people today facing this on a daily basis. This is obviously an issue that in this part of the world we're well aware of and have been for forever, but this issue is becoming global. Regions like California, where I lived for many years, as I mentioned, are experiencing more and more droughts. Regions like Europe, where I grew up, is also experiencing increasing frequent droughts. This is becoming a global concern. Again, from 700 million to 2 billion people facing regular droughts in the next 25 years. Next, we have labor shortages. That's a big concern in a lot of different regions in the world, not only in the US, but also in Europe, in China, in South America, and so on. This is actually a good news. You can argue that jobs on the field are some of the toughest jobs in any economy. So it's actually a good news that with the rising income levels of those different regions, these jobs are not attracting a lot of people. But it's obviously very bad news for farmers who rely on them to do their daily tasks. And with the increasing tensions related to immigrations in different parts of the world, this is becoming harder and harder for countries to compensate the lack of domestic labor with immigration. So that's a really big concern for a lot of farmers throughout the world. And then we have greenhouse gas emissions. At a recent COP, a few miles from here, and a few months ago, it was agreed upon that agriculture as an industry needs to first decrease by 25% greenhouse gas emissions by 2030. This is very, very soon, 6 years from now. And secondly, need to not only reach net zero emissions, but actually become a carbon negative industry by 2050. Needless to say, this is a huge challenge, and we're very far from there today. And then we have the land. Arable land is actually forecasted to slightly increase. That's a UN forecast, about 4%, represented here by the green line. But the problem is population is growing much faster. Today, there are about 7 billion people who can afford to have a healthy diet locally for them. By 2050, population growth will add 1.5 billion mouths to feed. And then another 0.5 or 500 million people will, that's a great news, get out of poverty. But what that means is that the 7 billion mouths to feed today are going to turn into 9 billion. So to be very concrete, 1 hectare of arable land today, on average, throughout the world, feeds 5 people. That's basic division between the two numbers. By 2050, we need that number to become 6. We essentially need to find a way for agriculture to feed a 6th person with the same land. So that's a challenge. Agriculture is facing a very big challenge, feeding more people by using the same amount of land, or about the same amount of land, drastically less water, drastically less labor, and drastically, almost zero, or even more than zero, negative carbon emissions. This is the great challenge. But I think it's also an amazing opportunity for agriculture to modernize. And as we'll see next, technology is becoming mature to start addressing these challenges. And I believe that the next 25 years are going to see tremendous amounts and rate of innovation throughout agriculture. Technologies that before were dedicated to other industries are going to make their way to agriculture. New technologies that other industries have not seen are going to appear first in agriculture. I believe, as we'll see next, that agriculture is going to be transformed drastically by technology over the next 25 years. So next, if you allow me, I'd like to take you on a little bit of a tour of the different technologies, some examples of different technologies. I spent the better part of the past 10 years working with farmers on one side, but also with engineers and technology providers for farmers. So I want to give you a little bit of a tour of examples of interesting technologies and companies I've seen. One critical technology that matured over the past 10 years is genetic engineering. CRISPR, the advances that have been made possible by the COVID vaccines development, as well as the continuously decreasing cost of DNA sequencing. These are general technologies that are allowing companies to create new solutions that are addressing farmers' problems. The first example here is called Pasture Biosciences. They're developing a vaccine, but not for humans, for cows. A vaccine that drastically decreases the amount of microbes in the cow's gut that are generating methane. This alone is responsible for, today, for 5% of greenhouse emissions, not of agriculture, but of society, of human-made emissions, 5%, cattle farming. So this has a huge potential. But also, this is a technology that, once developed, can scale very rapidly. A vaccine, as we've seen recently, is actually, once it's discovered, it's pretty fast to scale. So a huge opportunity here. Huge opportunity to decrease greenhouse gas emissions. The next example I have is Pivot Bio. They're using CRISPR to modify the genome of microbes that are then put on the ground that are helping plants fix nitrogen directly from the air. What that do is, first, reduce the amount of industrially made ammonia, which is the nitrogen fertilizer, that we need. And on the other side, actually enhances the amount of nitrogen that is kept by the plant. So it's good on both sides, less fertilizer and more absorption by the plant. So it has the potential to not only decrease greenhouse gas emissions, but also to increase yield per acre. So decrease the need for land for same production. Inari is a company that's performing a similar development, but on the seeds themselves. So they're using CRISPR as well to edit a few of the genes of plants to make them more efficient at capturing water, more efficient at capturing nitrogen. That has a huge potential to reduce water that we use to grow these plants, and potential to reduce the land that we grow these plants on, and obviously the potential to reduce industrially made fertilizer, and therefore greenhouse gas emissions. The next category of technologies that I'm personally excited about are new type of industrial processes. With data-driven industrial processes becoming more mature, electrolysis, or new electrolysis, and new fermentation processes, this is giving rise of a new set of companies in agriculture. An example I like is Verdegy. They're developing industrial-scale electrolyzers to make hydrogen from water. So you use water and renewable energies to make hydrogen, which replaces the carbon-emitting process of producing hydrogen today, which is responsible, again, for 7 to 8% of global emissions through the production of ammonia. So by scaling this technology, we can remove the carbon emissions of this process. Next, I want to talk about artificial intelligence and robotics. Obviously, these technologies have made headlines recently, and they're addressing some of agriculture problems in a very efficient way. Let me start by telling you a little bit about the company I co-founded about 8 years ago called FarmWise. At FarmWise, we essentially took recent advances in AI to build cameras and artificial intelligence algorithms onto farming machines. So what this does is it allows farming machines to see what's in front of them, understand where the plants are, what the plants are, what type of plants they are, and then what they need. And using this information in real time, the machine can decide what to do, when, how much chemicals to apply, or how to automate some tasks. So we're essentially adding eyes and brains on top of farming machines. We started to use this product in the US, and we're using it today to help with the mechanical weeding process, the actions of cutting out weeds on vegetable fields. Self-driving electric tractors are coming. This is a company called Monarch who's developing this technology, and they're starting to scale pretty rapidly in the grapes industry. Potential to obviously reduce CO2 emissions, but also remove some of the friction today to find tractor drivers, which again, in many parts of the world are a pretty scarce resource already. CropX. CropX is a very interesting company in my opinion because it really has an impact on many dimensions and in many regions of the world. They developed two things. One is a sensor that goes into the ground and measures things like electroconductivity of the ground, moisture, temperature. These parameters are actually correlated with how healthy the soil is and therefore how healthy the plants are. But then once they do that, they don't stop there. They also plug this technology with more data sources coming from satellite, coming from publicly available sources of information, and they build a comprehensive recipe or a baseline for farmers to use. Farmers are using it to essentially decide how much and when to water and how much and when to fertilize, both very critical informations. And so just by adding better data or better information, this company allows farmers to make better decisions. All right. Now, I want to just complete this tour with a couple of examples of pretty disruptive ideas that are having or have the potential, at least, to make a huge impact on the efficiency of agriculture in the next couple of decades. A couple of miles from here, we have a company called Bustanica, who's partnering with Emirates to provide very fresh food to their flights. If you followed the agriculture tech scenes over the past 18 months, you know that vertical farms are having a hard time in the US. So while vertical farming, I don't believe, is a one-size-fits-all solution for every part of the world and in any situation, when used properly on specific use cases like this, it can have a major impact. This is allowing Bustanica to grow food locally here in the UAE with drastically less water. This is another interesting technology. They are producing artificial fat, such as artificial butter. What's really interesting about this is that they are able to make butter that is chemically equivalent to regular cow-based butter. So not only can you not taste the difference, but there actually are no chemical differences. They start from CO2, actually, and through a sequence of different chemical processes, they essentially recombine the carbon carbon atoms into complex molecules called triglycerides that are the fats that we eat on a daily basis. So that has huge potential. It's not at scale yet, but it allows them to produce food with essentially no land, no water, no labor, and no even negative carbon emissions. It's pretty exciting. Obviously, I want to talk about lab-grown meat. This is a new technology that's getting closer and closer to being commercially available. This company got FDA approval in the US to start selling. What they do is they take stem cells from actual chickens and they grow the fibers that we all like in chicken's meat, and they grow it in the lab. Again, this has the potential to grow food with essentially almost zero land, water, labor, and carbon emissions. And to complete this tour, that's the last one, I want to just share a very simple idea that a company had based in Europe, because obviously I believe that high technology is critical to make that transition happen, but it's not only high technology. It's also smart ideas that uses technology to drastically improve processes. And this is an example. The company is called Too Good To Go. And as its name indicates, it matches stores and restaurants with consumers. Consumers essentially pay in advance, and at the end of the day, they get a surprise bag with leftovers from restaurants and stores. This is a win-win situation where consumers pay less for more food, and their stores get a few more bucks out of the food that they will have thrown away anyway. So a very interesting, simple idea that's growing really fast in Europe and in the US since more recently. And this is only the tip of the iceberg. There are many other technologies, and obviously I expect many more technologies to arrive over the next couple of years. And these technologies, in my opinion, are going to be critical if we are to achieve all of the objectives that we discussed before. But the thing is, today, a lot of these technologies are still pretty expensive. And when you visit a farm here or other parts of the world, in the US and Europe and South America, what you see is often not this. What you see is often something that looks closer to this. That's because these technologies are expensive. They take a long time to scale. And so these technologies need more engineers, innovators, investors, and obviously participating farmers to accelerate. So in order to end this presentation, I want to take a few minutes to talk about thoughts around how can we, not only as consumers, but leaders, innovators, and policymakers, help this transition to accelerate. Essentially, I think there are two sides. One is accelerating technology supply. This is going to come from making long-term investments, investing in technologies, and investing in companies that have a long-term horizon. Because a lot of these technologies, and particularly in the agriculture industry, take time to mature. So we need patient capital or long-term investors to get increasingly interested in this industry. And I think there should be. I think the challenges that we discussed are mirroring huge opportunities, both technical opportunities, societal opportunities, and financial opportunities. Matching programs. I think communication is obviously key. I've seen in different places in the world very successful programs that are essentially matching farmers with innovators or engineers and having them talk, sometimes directly, sometimes through an intermediary, like an association. That's very powerful because each side needs to build empathy for both of them to work together toward the same goal. So that's a powerful tool, in my opinion. And then we need to promote agriculture and technical fields in agriculture in universities, and even better before that, at school. I'm genuinely convinced that the next 25 years in agriculture are going to be extremely exciting for engineers and students. And so I think it's, as policymakers and leaders, it's our responsibility to show that to the younger generation. I think agriculture needs people with deep empathy for farmers and also deep expertise in technical fields. And then the second tool that I believe is key to accelerate this transition is increasing sustainability demand. That obviously goes through regulation, which I obviously, in general, in favor of. I just believe that there are obviously good and bad regulations. Just to give you one example, and not making any judgment here, but in my home country, there was this regulation that passed about 10 years ago, whose intention was obviously very good, which was to move away from chemical input in agriculture. The thing is, they put two ambitious goals with essentially very little solutions for farmers to actually find the right technologies, because these technologies did not exist at the time. That created a lot of frustration. And about 3 months ago, the government decided to essentially stop this initiative, which again had good intentions, for lack of solutions. So obviously regulations needs to be very in touch with what farmers can actually do. That's key. And the last thought I want to leave you with is that obviously all of us as consumers have a big role to play. I also believe that specific type of people, which we can call food influencers, have a specific role a very big role to play. These are chefs at restaurants, leaders of food chains or supermarkets. They can essentially show us the way. They can help us change our diet or make our diet evolve progressively by experimenting with new type of food. I mentioned artificial butter, I mentioned lab-grown meat, but that extends to favoring sustainable food over non-sustainable food. So I think they have a critical role to play. So to wrap up this presentation, I want to leave you all with 3 takeaways. The first one is that agriculture needs to evolve quickly. It needs to become drastically more sustainable on all of these different resources that we discussed, and it needs to do that while feeding more people, feeding a 6th person with every single hectare of land. Second, the future of agriculture is going to be very technical. We're going to see increasingly cutting-edge technology on the farm, and that's, I think, should be very exciting for everyone, and specifically for entrepreneurs and engineers. And last, promoting technology supply is obviously a necessary step, but we need to also, all of us, be conscious of the tremendous impact that demand has in this transition. We need to promote technology demand by promoting sustainability demand. And as a word of conclusion, I think the situation we're in right now is very similar to a situation the world was in about 120 years ago, where the supply of ammonia, the natural supply of ammonia, were getting exhausted. And 2 German scientists worked for about 15 years to develop what became the only process by which we now produce artificial ammonia to fertilize every single field in the world. The world was, at the time, was facing a huge problem with a resource that was getting depleted. Today, we're in a very similar situation, but it's not only one resource, it's several resources that are getting exhausted. And I think a similar answer is going to be the path forward, which is technical innovation at scale. Thank you very much for your time, and I'm looking forward to continuing the discussion with Ms. Leila.
Thank you, Mr. Boyer, for your valuable insights. I'd like to commence now with a few questions,
Sure.
a Q&A session. You highlighted quite heavily the importance of food systems in agriculture when it comes to food and water security, but also the critical element that it has within the nature and climate nexus. And this is because of the fact that agriculture has an impact on soil, on water, and on greenhouse gas emissions. Now, here in the UAE, we work collectively amongst different stakeholders to implement principles of agroecology, which you've also highlighted, circular farming practices, as well as nature-based solutions, as a way to develop more sustainable and resilient communities in the long run. How do you envision leveraging technology and AI-driven precision tools? And maybe if you can focus more on the climate adaptation-based AI tools that show promise in climate-proofing agriculture and food systems.
Sure. So as I mentioned, I think technology is going to be the main tool, right? So to advance those goals. There's one example I find fascinating, which is the ability for AI, it's a similar technology than the one we developed at FarmWise, which is the ability for AI to make way more precise decisions. So when agriculture, up until recently or even today, used to be a one decision per field type of process, I think we can enter a world very soon where decisions are being made at the plant level by using AI that's essentially making millions of decisions per second. And that's going to allow us to be drastically more efficient with the resources. This is true for water, for fertilizer, also for pesticides. So the ability for AI to, for instance, for vision-based system to recognize plants, but also in general for better measurements and better decision-making processes, the ability of these technology to allow the decision makers to make 1 million decisions per second is very exciting to me. And I think will advance us drastically toward the goals that you mentioned.
Brilliant, thank you for that. My next question is actually focused more on the adoption of these technologies with local farmers. The collaboration and support of local farmers, as you know, is instrumental. They play a very critical role within the agricultural communities. From an NGO perspective, we prioritize really fostering those relationships with local farmers, building trust, but essentially blending local ecological knowledge with cutting-edge science and agroecology, exemplified by initiatives such as piloting sustainable model farms and looking at how do you diversify the existing crops to be more climate resilient. Now, given your experience and drawing from all of the insights that you shared, what can we learn regarding the acceptance and integration of technology within rural communities? And how do you foster the uptake and adoption of these innovative technologies amongst farmers within those rural communities?
Yeah, thanks for your question. I think that's a critical question. The adoption of the technology by farmers, like literally on the field. I think it's a tough topic, but I think there are things that we can do to make it a little bit easier. I think a lot of these things have to do with information. One of the big problems I see for a lot of agtech companies is that it's very hard to build solutions without building empathy for farmers. So I think there is a challenge on the innovator side to really build that empathy, that muscle, that mental muscle, about how farmers think, what their problems actually are. Because at the end of the day, like, you may want to impact sustainability, but in order for your technology or your solution in general to be adopted, it needs to solve a problem, like a concrete problem that farmers have today. That's a little bit of a challenge, right? Because innovators tend to think 10, 15, 20 years ahead, which is good. But farmers have to grow crop and make a living today or tomorrow or next week. So that's a challenge. So I think having more bridges in terms of communication, that's good. I think it also goes the other way, where farmers can build empathy for technology or for innovators, at least being more aware of what technology exists, how far along they are in their development, what other farmers have used successfully or not. And I think governments or local entities can play a big role in kind of creating that structure for both sides to meet.
Brilliant, thank you. My next question is a little bit more UAE specific.
Okay.
But essentially, many local farms here utilize a century-old irrigation system. It's called the felaj. And this acts as a symbol of our cultural heritage. It's been there for centuries, and many efforts are underway to preserve the felaj. And the reason for this is not only to sustain essentially agricultural and water supplies and benefits to the farmers and the local environment surrounding it, but for us it's important to also ensure that we're contributing to the preservation of local culture and local traditions. So how do you approach the integration of such rich traditional wisdom with cutting-edge technology? So how do you fuse essentially modern technology with that traditional knowledge, and how do you approach those particular situations?
Fascinating question. I think what's interesting is that the agriculture industry in every single region in the world is really closely intertwined with the social and historical mesh that society is built on. So it's not only, I'll try to answer for the UAE, but I think it's not only a UAE question. I think it's a question a lot of regions are asking themselves. Again, just taking the example of some of the countries I know, like in my home country, France, the social mesh that farmers represent matters a lot to people in general and to society, and plays a big role in agricultural policies that the government is putting in place. So I think it's critical to take that into account when thinking about policies in agriculture. I also think that tradition obviously is not stagnation, and we're here in front of this magnificent, great mosque, and this is, to me, a testament of this statement. So I think the way forward is to make farmers realize and make community realize that we can combine both, right? We have to combine both. Like, there is no solution that is going to be able to scale without meeting both criteria. So I think it goes back a little bit to the question before, where by building empathy between innovators and farmers, they can see all the dimensions. So not only the technical dimensions, or like, this works in my lab, so I'm happy, but also the psychological dimension, the traditional dimension, the social dimensions of their solutions. And I believe that it's only by taking these other dimensions into account that they can create, and then provide successful solutions that are going to be able to scale.
Brilliant. Thank you for that. I have one last question. While implementing ag tech at scale, there's certainly a responsibility to ensure that it's done in a clean way. And I think you've illustrated a lot of examples here today where you factored in how do you minimize the use of emission-heavy energy sources to fuel that ag tech with the electric vehicles that are used within the farming industry and so forth, and to ensure that there's no long-lasting harm to the environment. But how can we improve that environmental track record of ag tech as well globally around the world? I think you've done an excellent approach at that, but how do we encourage more of that globally?
Yeah, so obviously, technology we just talked about, so that's a big pillar in improving the overall environmental footprint of agriculture. There are other things, obviously, regulation. I think better measures, like measuring better tools, both technology and processes and policies, to measure this impact, obviously is critical. I think one of the biggest pillars, in my opinion, that I mentioned at the end of the presentation is the demand side. Having people, consumers, and again, particularly those influencers that I mentioned, realize that every decision you make when you purchase a meal is a vote that you make on the environment. Having people realize that, and having people start to internalize the externalities that agriculture does have on the environment, that I think is probably the most powerful tool that we have. Because at the end of the day, farmers need to make a living. Like, they are working with constraints, and they're working to do the best they can to make a living within those constraints. So it's only, in my opinion, by having consumers and the demand side really pull the technology forward that we'll see that transition really happen fast in the next few years.
Thank you. Thank you so much, Mr. Boyer, for the valuable information that you've shared with us here today within this space. I extend my sincere thanks to Your Highness for gracing us with your presence. Once again to Sebastian Boyer for his expertise, and all the esteemed guests. It's now my honor to invite His Highness and the participants from the introductory video on stage to join us for a group photo. Thank you very much.
لمسات إبداعية.